is about something called sequences. So we'll definitely sort of get into that over the next couple of lessons. It starts with this question, multiplying like bunnies. And by the way, we'll be looking at a new kind of a graph. It's called exponential growth. It's one of my favorite things. It's pretty cool. Anyways, multiplying like bunnies. In the book of Mice and Men by John Steinbeck, great book. Two good friends named Lenny and George dream of raising rabbits and living off the land. What if their dream came true? Suppose Lenny and George started with 2 rabbits, and during the first month, those rabbits have 2 babies. Suppose that every month thereafter, each pair of rabbits has 2 babies. So with your team, determine how many rabbits they would have after 1 year. Represent the situation with a written description of growth, a diagram, and a table. And state the assumptions you made and compare any patterns you find. So let me see. I'm going to go down here and give myself a little bit of room. Further guidance, 5.2 basically talks you through if you were a little bit stuck on this problem and you weren't really sure. It kind of gives you some hints to go through to work with. I don't know. What strategies can you hope to keep track of the rabbits? What patterns can you see in the growth? Okay, so just some kind of things to think about as we go. But again, I don't really think we need those, so I'm going to get rid of them. So let's start. They start with 2 rabbits. So at the beginning, they have 2 rabbits. So this will be how many months. I'll just make a table, and this will be how many rabbits. So I'm going to say at time 0, they had 2 rabbits because that's what they started with. So these 2 rabbits after a month are going to have 2 more rabbits. So I'm up to 4 rabbits. Now, the next month, these 2 rabbits, again, are going to have 2 more rabbits. But what's new is that these 2 rabbits are also going to have 2 rabbits. So you can see I have 8 rabbits after the second month. The third month, these 2 rabbits will have 2 rabbits. I'm kind of running out of room, so I'll just say these 2 rabbits will have 2 rabbits. These 2 rabbits will have 2 rabbits. And these 2 rabbits will have 2 rabbits. So I have 2, 4, 6, 8, 10, 12, 14, 16. And at this point, I'm kind of tired of drawing dots, and I hope that you look at the table and begin to see what's going on here. It looks like it's doubling each time. So I would say this would go to 32, this would go to 64, this would go to 128. Remember, we're trying to figure out how many they have after 12 months. So this would go to 256. I'm kind of running out of room here, so I'll go over here. This would be 512. This would be 1,024. This would be 2,048. This would be 4,096. And I think this one would be 8192, but this would be month 12. So let's go ahead and see here if that's correct. 4096 times 2. It was 8192. So we have 8,192 rabbits after 1 year. Represent this. Well, it's doubling each month, so that would be my description. The diagram, well, I have the table right here, and the diagram would be kind of interesting because it starts so low, but you can see it gets up to like 10, up into the 10,000 range, right? So, I mean, it's growing significantly. Again, this will be how many rabbits, and this will be months. And, you know, this is not the world's greatest graph, and I don't really care. I'm just sort of, I want you to see the shape of this. So it starts with 0 and 2, and then it goes to 1 and 4, and then 2 and 8, and 3 and 16, and then 4 and 32, and 5 and 64. And you can see on a scale of 5,000, it doesn't even really move. 6 to 128, 7 to 256, 8 to 512. I think that actually says 50,000. That should just be 5,000. 8 would be 512. 9 is 1,000. So now we're at least starting to register a little bit on the scale. 10 goes to 2,000. 11 goes to 4,000. and 12 goes to 8,000. So I hope you see what's going on here. We have this pretty distinct curve where it's flat for a while, but then it really starts to increase rather quickly. And that's what happens when you double something each month, right? When the numbers are small, the doubling isn't that big of a deal. But when the numbers get large, the doubles become pretty significant. So that's one of the tricks with the exponential curve that we're going to discuss in this chapter, and why it's so important. All right, so let's go ahead and move along here and keep going. So, like I said, 5.2 just sort of gives you some suggestions that kind of come through with that. So we'll kind of skip through 5.2 and then we'll jump up to 5.3. Lenny and George want to raise as many rabbits as possible, so they have a few options to consider. They could start with a larger number of rabbits, or they could raise a breed of rabbits that reproduces faster. How do you think each of these options would change the pattern of growth you observed from 5.1? Which situation will yield the largest number of rabbits after 1 year? So help to answer these questions. Model each case below with a table for the first 5 months. So they just want us to go through the first 5 months. So we'll just go one at a time here. So let's see here. So trying to get a feel for which of these would win. So we have 10 rabbits. So on case 2, we have, and of course X will still be months and Y will still be the amount of rabbits. So we have 10 rabbits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They each pair has 2 babies. So this pair has 2 babies, 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 and this pair has 2 babies. So I have 4, 8, 12, 16, 20 rabbits. I get the feeling that I will have 40 rabbits right here. So let's see. These 2 will have 2. These 2 will have 2. These 2 will have 2. 2 here. 2 here. 2 here. I know this is kind of a pain. So I guess if you're making your own dots, you can keep better track than I am. But I have 8 here. I have 16. 24, 32, and 40. So I did have 40. So I feel pretty comfortable. I'm just going to have 80, and then I'm going to have 160, and then I'm going to have 320. So that would be the first 5 months there. So let's see if I can do this without erasing everything, and I cannot. So I will just jot in here that I have 320 after 5 months. Now let's go with apologize here. This is definitely not as functional as I would like it. All right, so let's try the second one here. What if we start with 2 rabbits, but each pair has 4 babies? So now we start with 2 rabbits, and each pair has 4. So I would have 6 at the end of the first month. Then these 2 would have 4. These 2 would have 4. And these 2 would have 4. So at the end of the second month, I would have 6, 12, 18 rabbits. Looks like it's multiplying by 3. So I'm not sure I really want to keep going with this. It grows pretty quickly, so it does keep growing by 3, so this will be 54, this will be 162, and this will be 486. So you'll notice that even though we start with less rabbits in this example, it grows rather quickly. So we can assume that case 3 is going to definitely beat case 2, and even though it starts with less, the fact that it's going by 4 is going to be more. Well, I think it's not that difficult to see case 4 is going to end up being the winner here, right? Because same as case 2, but now they have 6 babies each. So let's go ahead and let's take a look at that. I think it actually be easier to just draw a brand new white one over it. Okay, so we start with 2 babies now. And each month we get 6 more babies. So we'll say I have 8 after the first month. Now these two will have 6. These two will have 6. These two will have 6. And these two will have 6. So you can see I have 8, 16, 24, 32. So on this one, it looks like we're multiplying by 4. So probably going to grab a calculator on this to help me out. So I'm going to have 32 divided by 4. So I will go to 128 to 512 and 2048. So 128, 512, and 2048. So you can see just how much of a difference these 2 extra babies make, because that makes another pair each month, and that pair each month will have 6 more babies, and then so on and so forth. So it really just begins to snowball on itself and gets a lot bigger. So which case will give Lenny and George the most rabbits after 1 year? I think it's without question case 4. How many rabbits would they have in that case? Well, let's see here. So we're at 5 months. So we'll just keep going on this calculator. So, I hate the way these calculators work sometimes. Okay, so we'll say times 4. That's 6 months. 7 months. 8 months. 9 months. Look how gigantic these numbers are going. 10 months. 11 months. And 12 months. I'm getting 33 million rabbits. What is that? 1, 2, 3, 1, 2, 3. Yeah, 33.5 million rabbits. So I don't know if I might have screwed something up there, but I'm getting a large amount of rabbits. Let me go ahead and pause the video and just make sure that number is correct. Did end up being correct. Like I said, I knew it would be a large number, but I think I was still taken a little bit aback by going from 2 rabbits to 33 million in 1 year, based on those numbers. So I did kind of skip over one problem in 5.1, I think it was, asking what assumptions we're making. We're making the assumption that these rabbits will always reproduce at this rate, never more, never less. None will ever get sick. None will ever die. That we can feed them all, etc. So there's a lot of assumptions that we're making that in real life probably wouldn't end up being true. So anyways, on 5.4, it says a new family of functions. Look back at the tables you created in the previous problem. So obviously my tables are gone now, but hopefully we remember that some were doubling, some were tripling, and some were quadrupling. What do they have in common? So functions that grow that have this pattern are called exponential functions. So what they had in common again was that they had a common multiplier. Some were doubling, some were tripling, some were growing by 4. But the idea was that we knew that they were actually multiplying. They had a common multiplier, not a common difference. They didn't add each time; they multiplied each time. So instead of like in a line where it adds 3 each time, this one it curved each time. So it multiplied by 3, then multiplied by 3, and as the numbers got bigger, multiplying by 3 makes a bigger difference. So let's go ahead and take a look at this. It says obtain 511 resource page from your teacher, which I'll show you in a second, and graph the data for case 2. Write a complete description. So if I remember correctly, I think case 2 was the one where we started with 10 and then it doubled each time. So we're going to go ahead, and this is kind of a pain the way the software works. It should just let me open something, but it doesn't. So it always kind of freezes the software. So it wants us to just graph this for the first few months. So we started with 10, and then at the end of the first month, that doubled to 20. At the end of the second month, that doubled to 40. At the end of the third month, that doubled to 80. Fourth month, it went to 160. And then it went to fifth month up to 320. And I'll just leave this. Was it case 2? I think it might have been case 2. not case B. Okay, so some thoughts here. Should this be continuous or should this be discrete? Well, this is kind of an interesting question. So continuous means that I'm just going to connect these points. Discrete means that it jumps from 1 to 1 to 1. So in order for it to be continuous and me to connect these dots, I have to be able to have a partial month and a partial bunny. Well, without getting too much into this, it does make sense to have a partial month, right? 2.25 months is just 2 months and a week. However, I wouldn't have 40.7 rabbits. Having a 40.7 rabbits is a lot the same as having 40 rabbits. So I don't want to go too much into great detail on this, but the idea would be that essentially this is what case 2 is going to look like. Maybe if we wanted to have some more discrete points along the way, we could, but at this we'll just sort of leave it at that. I don't know, just kind of jumping around. I don't know exactly what they're asking me to do in those problems. So I'm gonna put all 4 cases up here just so we can see the differences. Case 1, we started with 2 rabbits, I think, and it doubled each time. So it went to 4, then it went to 8, then it went to 16, and then it went to 32, and then it went to 64. So you can see case 1 was not terribly exciting. It didn't get to do too much on this graph for the first 5 months. If we go to case 3, I think that was the one that started at 2 and then it started tripling, right? So it went from 2 to 6 to 18 to 54, 162, I think. And then at that point, 162 is going to be 480 something. So, case 3 was going to be somewhere way up here. It was already off our graph. And then finally, case 4, again, we started with 2, but then it was quadrupling each time. So that went to 8. And then it went to 32. And then it went to 128, I think. And then you can see, right, I'm already kind of running out. Like case 4 was kind of way up here. It was already sort of running away, and this wouldn't even begin to contain it. Actually, I guess I should have put the point more over here, not over here. But the idea being that it was growing significantly faster than the others. So let's go back and just answer the last couple of questions for this lesson, and we will call it a day at that. So again, we graph those things. It says answer these questions. What did I just do? I apparently accidentally deleted that, which is unfortunate. Okay. So we graph that. Answer these questions about the graph if you've not done so already. What's the domain and range of the data? Well, the domain went from 0 to 5 months, and the range went from 2 rabbits. I think we started with 2 up to, I don't know, however many hundreds of rabbits that we had. We already answered the question, is this continuous or discrete? Well, we would say that it is discrete because we can't have a partial bunny. And is it a function? I would say yes, for sure it's a function. Each input had one individual output, right? So that's, if you'll recall, that's what a function is, that each input, if I tell you how many months, you have to tell me how many rabbits I have at that month, right? So it wasn't like you were telling me, oh, you'll have this many or this many. For each individual case, right? I mean, obviously the 4 cases had different answers, but when we looked at only one case at a time. So that is an introduction to Chapter 5.